So firstly, right, on behalf of the SES Free and Open Source Software SIG, would like to thank everyone, especially at this time of the day, right, for spending your afternoon to attend this webinar. So today, as you guys know, we're going to talk about Terraform. So as you know, right, Terraform is one of the tools that is actually being used by a lot of developers today to create flexible infrastructure, and also be used for mostly in the cloud space when it comes to provisioning of resources. So today, right, we are going to be talking about what Terraform is and how it works. And with that, right, I would like to introduce our speaker, Adrian Lee. So Adrian is actually a friend of mine who has been working on the private and public cloud deployment. He also been working on the open source projects, doing POCs for customers, covering things like Kubernetes and also cloud native applications, covering different types of languages like Node.js, Python, Go. So he's also a certified Kubernetes administrator and also a certified Kubernetes application developer. Obviously, if you're involved so much in the cloud space, you can't escape from using Terraform. So today, he will be sharing a bit more about how Terraform works, more of an overview. And of course, feel free to, if you have any questions that you want to ask, right, you can actually post it on the chat. A bit of disclaimer. So this recording will be, this presentation will be recorded. So if let's say that any of you do not give your consent to recording, right, as you can see from the screen, please feel free to turn off your camera and change your Zoom name, because the content that is used, that's going to be recorded will be used for marketing purpose for SES as well. Okay, so without further ado, Adrian, I will hand it over to you.
Yep, sure. Okay, so hi everyone. Good evening. Yeah, good evening. Thanks very much for you guys being here on Friday afternoon. So my name is Adrian. As Wai Xiang said earlier, just a little bit of background about myself. I like doing software development. I do automations. I do solutions architecture. In my spare time, I do running. So it's not all just work. I also actually enjoy learning new things. So for myself personally, I'm actually taking a master's at NUS just to increase my knowledge. I have taken a few certifications, but I don't think that is just the limit of knowledge. I think actually practicing it in a daily life it is more important. So that is something which I believe. And I think one thing to note is that it's always important to continue learning about new things and items, especially in the IT industry, because it's ever changing. This is my GitHub, and you can connect to me via GitHub. Feel free to ping me. I have a few repos of Terraform up there, Kubernetes demos, so feel free to look through. Okay, so without further ado, I just want to give context in terms of the agenda. I want to run through basically the state of things. Then followed up by Terraform 101. So I understand on the call that there will definitely be greater, maybe even stronger Terraform experts. This is the 101, showing you how to actually use Terraform, as well as to scale up your infrastructure. And then lastly is that I'm showing with a CI/CD demo with Terraform. Okay, so before I begin, this is a code which I actually use, I took very recently from a class which I took at NUS, which is actually what is infrastructure as code. So basically what it means is that we use code to describe infrastructure, and everyone is using tested code for the infrastructure management for his own implementation. We want to achieve automated operations. We want to achieve use software development practices to apply to infrastructure. So what is the state of things now in terms of the infrastructure as code space? So as you can see, there's a lot of players in the environment. You have Terraform, naturally, which is what I'm talking about today. You have Ansible, which is configuration management and as well as infrastructure automation. You have Puppet. Puppet does your configuration management as well. You have AWS CloudFormation, which is very specific to AWS. You can actually CloudFormation your resources on AWS. And like, for example, you have VMware vRealize Suite, which does actually automation for both private cloud and public cloud through a GUI. So there are a lot of actually different tool sets and as well as technologies that you can actually use today. But in particular, just for this session today, I'm focusing solely on Terraform. So Terraform, if you do not know already, it actually comes from HashiCorp. And HashiCorp was actually established for achieving the idea of actually multi-cloud infrastructure. So in total, they have about 6 products. if you see from left to right, these are the 6 products. So Terraform is on the left. Next is actually Vault. Vault is for security management or keeping of secure keys. You have Nomad, which is actually doing application orchestration. We have Conceal. Conceal is actually a network service discovery solution. Then you have Packer. So Packer actually does the packaging of your VMs. And then Vagrant. So Vagrant is like, for example, also packaging of your VMs and getting it up. So in particular, I'm focusing on Terraform today. So Terraform, as defined by HashiCorp, is actually a tool for building, changing, and versioning your infrastructure safely and efficiently. Okay, so one of the key things about Terraform, I think in the context of the 101 today, is that first and foremost, it is a declarative language. So what does it mean by that? What happens is that we want to achieve infrastructure states currently, and gone are the days where we treat infrastructure as cattle. Now we treat them, we now treat them more like cattle rather than pets. And what it means is like, for example, right now I want to achieve the state of I want 10 servers to be deployed, be it on AWS, GCP, Azure, or on-prem. So if I'm using Ansible and Terraform, right? Actually, if I'm using Ansible, I can achieve it. I can achieve it in this manner. For example, I can just put a count of 10 and I'll put in the image and instance type. Terraform as well, I can achieve the same item. But so then you might be asking, then what's the difference between Terraform and Ansible? I just might as well use Ansible. So it comes when, so 10 servers are being deployed. It comes when now I want to deploy, like for example, from 10, I want to now shift to 15 servers. In totality, I want 15. In Ansible, however, right, what happens is that when you apply count of 15 in Ansible, it will deploy total of 25 because I had 10 earlier plus 15 equals to 25. But for Terraform, what happens is that when I change the state file, right, the TF file, what happens is that it recognizes I need 15 servers and it will just deploy an additional 5. So what this means is that in terms of deploying code, for example, using Ansible, I do not need to actually maintain a separate state of my code, right, to just actually plus another 5. I do not need to do that. Terraform, on the other hand, it will actually allow me to dynamically change the amount of resources that I need. So that is what I mean by it's declarative, and it is just think of it like, for example, Terraform is like your Grab or Uber. You want to achieve, like for example, going to a certain place. You don't care how you get there. You just want to get there. So Terraform gets you there, basically. Okay. Another thing about declarative is that we declare the end state. So for just now, for example, I want 15 servers and I want 15 EC2 in, let's say, AWS. Terraform figures how to get there, like as mentioned, like a Grab driver. You leave the Grab driver to figure out how he wants to actually move from that state, transition from a state where you have no infrastructure into a state of 15 infrastructure or 15 VMs. Okay. And actually, there are actually three items for Terraform. There's always Terraform Plan, init, Terraform Plan, and Terraform Apply. So for example, what you see on the left, right, is actually the main.tf file. This is where later I'll be doing a short demo and just as well as a run through so that you guys can understand how does Terraform work. Basically, that is where I define my code and deploy my infrastructure there. After that, what happens is that I do a plan. So a plan does something like scheduling. It checks whether if, like, for example, my syntaxes are correct, my modules are correct, whether I am actually using the right images, if I did tagging correctly. After that, it doesn't, so the plan does not actually deploy the infrastructure. Only when you do Terraform Apply, right, then the infrastructure is being deployed into, like, say, your AWS, GCP, or Azure, or VMware, for example. Okay, the other thing about Terraform is that it is highly pluggable. Okay, so what do I mean by highly pluggable? It actually end states to basically different public and private cloud deployments. So for example, Amazon, it can Terraform your EC2, it can Terraform S3, it can Terraform, let's say, Route 53, it can Terraform, like, let's say, your RDS, it can Terraform items such as like, well, blockchain, I'm not sure, but I'm pretty sure that EKS, it can be done. Google Cloud, for example, if I need a state machine, or let's say, for example, I need a BigQuery to be up, you can Terraform that. If let's say Microsoft Azure, on the other hand, I need a VNet to be up, you can Terraform. VMware, for example, if I need, like, for example, vSphere on premise and I need NSX, or if I need VMC on AWS, for example, which is basically VMware Cloud on AWS, I can Terraform that as well. So it is a provider where it actually connects to different public clouds and as well as private clouds. So that's what I mean by pluggable. Okay, as mentioned earlier, Terraform follows 3 very simple commands: Terraform init, Terraform plan, Terraform apply. That's kind of like the most basic things that if this is the one thing that you need to take away from this session, these 3 steps are the most important things: init, plan, and apply for Terraform. So just going through a bit about what is the different states. So Terraform init just basically initializes the Terraform libraries and binaries, as you might say. Terraform plan, what it does is that it does an execution plan for the Terraform. So for example, on my left, right, if you see the star.tf, that is my TF state. This is my TF file. So in there is where I write all my code. Like for example, I want 4 servers, 3 servers, I need an RDS. And basically what happens is that when I do a Terraform plan, the plan isn't being executed into AWS, GCP, Azure, and VMware. So if you look at the TF state file on the right here, you can see that it will just say like Terraform version, what's the lineage, outputs, resources. Nothing has been applied yet. Only when I actually do a Terraform apply, okay, and later I can let you take a look at my Terraform TF state file, it will build the infrastructure according to the star.tf file. So for example, if I need a VPC, EC2 instances, right, it will then after start to deploy that, and then the state is then being saved in the TF state file. So normally when you actually have a group of developers working on Terraform, for example, what happens is that usually the TF state file, you do not save it locally. You will save it in a backend, backend storage, for example, be it S3. In my demo later, I'm actually storing my TF state file in S3. The reason why is that so that if let's say me as a developer, one day I decide to leave the company, but you need someone else to manage the state of the infrastructure, right? That is where you have your TF state files, which are being shared across different developers. Of course, from Terraform, what happens is that they have their own cloud version, which is called Terraform Cloud. And what happens is that you can actually, it is like a public cloud version. And what happens is that you can use it to actually do your Terraform deployment. So you do not need to, like, for example, deploy a separate EC2 instance or VM instance and just install solely Terraform inside. You can use Terraform Cloud to do it. Okay, so just want to pause here for a quick while, and I just want to quickly take in any questions that you guys have first. Let me just do a quick read out in the chat. Okay, Fahim was asking is, can we use these products in combination? I believe, Fahim, you're asking with regards to, let's say, Terraform Vault and as well as like Consul. Are you asking that?
Yes, correct.
Yes, so yes, in fact, my demo later, right, I'm actually combining Terraform with Vault. So Vault is actually storing my MongoDB data. Not MongoDB data, it's storing a secret to my Mongo database. And basically what happens is that Mongo database will then actually use Vault to actually read the credentials and then after read the data from MongoDB. So you can use it in combination, no issues. If I need to migrate from one.
Sorry, in addition to that, right, actually my question was also pertaining to the Ansible and the other products which you showed in the previous slide.
Yeah,
so
sure.
Whether we can use these products in a combination as well, like if
Yeah,
I want
sure.
to use Ansible and Terraform together to manage the infra.
Yeah, sure, why not? So like, for example, if let's say from Terraform, right, if let's say I have Ansible, okay, I mean, Terraform does some things that are really fantastic, like infrastructure automation is extremely good. But when we talk about configuration management, right, it uses something called the remote exec, which we can actually use to deploy. Let's say I want to do a yum install of a certain library, or if I want to do an apt get, I can use the local exec. But I can also embed an Ansible playbook inside my Terraform and call the Ansible playbook inside. So it's definitely possible. Yes. If need to migrate from one cloud to another, can we use the same Terraform state? So Terraform states are usually more specific to the infrastructure setup. For example, a Terraform, for example, file, right? TF state file will say, like, for example, these EC2 instances are being deployed in this AWS environment. And currently, like for example, I have 4 EC2 instances and maybe an RDS, for example. So you cannot really take that TS state file because it's AWS specific, right, and apply it to maybe I'm talking about the TS state file. You cannot apply it very specifically to like GCP. Rather for Terraform, on the other hand, you have to edit the Terraform file to actually change it to whatever resource provisioning is actually in, like for example, in Azure or let's say in GCP. Yeah. So Terraform state files are more or less tagged to the infrastructure that you're using. Okay, so how different is it from Puppet? So Puppet is actually it's similar to Ansible in the sense that it does configuration management. Terraform actually, I would say is actually it's more a declarative approach, I would say, as compared to Puppet. Puppet, if I'm not wrong, also you need to install an agent to actually set it up. Ansible, on the other hand, is agentless. Chef also you need to install an agent if you do not know Chef. But Terraform is agentless and it's more declarative. It feels almost like writing a piece of code like that when you're using Terraform. AWS provides CloudFormation over Terraform. Does that mean using Terraform and AWS cloud setup has any drawbacks compared to using it with Google or Oracle Cloud? Okay, so AWS, right, for example, they promote CloudFormation, and okay, so don't get me wrong, CloudFormation is great as well. It does things that, for example, in the GUI format, for example, which is very specific to AWS, which I need. But of course, I can achieve the same result, right, using Terraform, for example. And I would say that I guess that CloudFormation, right, is very specific to AWS. So for example, if you have been working with CloudFormation all your life and you only know CloudFormation all your life, one day, if let's say you decide to port over to GCP, or if you decide to port over to, let's say, vSphere, or you decide to port over to Azure, right, then how are you going to transform that CloudFormation template into that public cloud or that private cloud language? You can't, right? So Terraform, on the other hand, allows you to change it from a syntax perspective. It is more of like you just need to change the provisioner and choose the resources that are needed to that particular particular cloud. Yeah. So for Terraform, yes, the state file at this point of time is the only way to store the state. Does Terraform have a similar design tool? So okay, so CloudFormation, it has the designer tool, correct? Terraform at this point of time doesn't really have a designer tool. More of it is it's more written from code. That's why it's being called as the infrastructure as code tool stack. So at this point in time, from what I know, at least there is not really a designer. Of course, there is, like for example, VMware. So VMware, we realize what happens is that it does do a GUI kind of format, and what happens is that it connects into the Terraform APIs. So VMware does provide one set of tool sets where that does a GUI-like syntax, a GUI-like interface, but Terraform natively, if I'm not wrong, it doesn't have it. I may be wrong, but that's what I remember. Okay, so right now I hope that addresses everyone's questions. For now, let me just move on to a very quick demo to show how it works. So in terms of GUI, right, the only way that you can, okay, it's not really a GUI as well, but the only way that you can see the whole Terraform estate, right, is if you use something called a Terraform graph. So when you actually do a Terraform graph, you can see, like, for example, I need an AWS instance. Here's my provider, here's my region, access key, my pub key, what are my variables, and actually what is the root resource. So to people who are not familiar with Terraform, okay, I'm going to do a very simple demo, right, where basically I'm going to Terraform EC2 instance. So give me a second. So yeah, my computer is a bit slow. Okay, so right now, the most important thing for Terraform, right, to note, right, is that first and foremost, right, you should always have the required version. Be it, I think now the version from Terraform, right, is 0.12, and I'm using Visual Studio Code. You can install Terraform as a Visual Studio Code plugin inside. It's not an issue. So these are various variables which I actually am using. Oh, sorry, am I screen sharing? Okay, yeah, I am, sorry. Yeah, so here's the variables which I'm doing, like for example, my SSH port, what's my user, where's my key, and as well as my public key. So I'm going to start writing a very simple code. Okay, so I'm going to do it on AWS. So for example, I'll write provider AWS, and I'll do like region equals to var.region, as well as secret access key equals to, sorry, access key equals to var.access key, and then secret key to var.secret. Okay, so for provider, you must always declare this first. And then next, right, what I'm going to do is that I'm going to Terraform actually a resource. So right now I'm going to do resource. So I'm referring to the docs as well so that I can remember. So I'm just going to do AWS instance. I'm going to do an example. Okay, and right, I am going to do Amy equals to, so I'm going to set a, so because it's just for demo purposes, I am actually choosing a specified Amy image, but of course, Terraform, you can do lookups where basically you can choose, like, for example, Amy images that you need. For those who are not familiar with AWS, right, Amy is basically the, like you can see the type of VMs that they encode for AWS. Yeah. Okay, so I'm going to provision a T2 micro. So of course here you can create a lookup table to do, like, for example, I need XL size or medium. Right now I'm going to attach a public key name. Okay, so this is where my key comes in. $var. Okay, sorry, give me a second. var.x. So this is where I'm attaching my public key. Okay, and then after that, later, I'm just going to do a text. I'm going to just tag this. So I'm going to say names equals to sample demo, for example. Okay, so this looks good. The last step that I'm going to do is that I'm going to, anyway, for Terraform, right, this is your main.tf file. If you're wondering, this is your main.tf file. The language that actually Terraform uses is actually called HCL, which stands for HashiCorp Markup Language. It's a very specific language that actually HashiCorp created. So right now, I'll just output my address because that's the address of my VM that I want. And for this, I would just do a value equals to, I can do AWS instance. Example star.public IP. Okay, so a neat trick for Terraform is that if I want to I want to format my main.tf file, I just need to do Terraform main format, and you see that everything is all formatted nice and easily. So awesome, great. So it looks everything is okay. First and foremost, I'm going to do a Terraform plan. So when you do a Terraform plan, right, what happens is that, as mentioned, it will look through your state of your infrastructure. It will actually check, for example, anything that is wrong. Okay, so it looks okay so far. Nothing seems to be wrong, right? So right now I will do a Terraform apply. So when you do a Terraform apply, right, what happens is that in Terraform is going to ask you yes or no, and basically they will ask you what is the key value pair that you want, whether it's a yes or no. So right now I'm going to enter yes because I want to deploy my infrastructure. So you can see that actually it's creating my instance already. So if I go over to AWS, take a look. Okay, you can see that it's starting to initialize already, starting to come up. Yeah, it's still creating, let it create. But just as a navigation, right, if I go over while it's deploying at the same time, right, what happens is that if we go into S3, So the Terraform state file, right, is actually being persisted here. I forced it to actually persist here. And the way I actually did it was by doing this. So if I open my editor, right, if I actually go to backend.tf, I can state what is the bucket that I want, what is the key, and which region that is at. So if you're thinking about from a software development perspective, right, maybe me as an infrastructure engineer, I go on leave today, someone else can access that TF state file. And from the TF state file, right, they can then after that use it to manage the resources in AWS, for example. Okay, so it looks like my VM has been up already. Let's just do a quick check just to see that everything's okay. Okay, so it looks good. It seems to be up, and here's my IP that I already have, for example. It's all good and well, and I didn't install any additional thing. So then comes the question, right? What if, let's say, you know, in my presentation just now, I was saying that, so this is the first demo. Now, let's say I want to increase the count. I want to jump from 1 to 2, okay? So what happens, okay? So as we remember just now, remember what I said, it always achieves the state. I now want 2 resources. So effectively, I have 1 up there, which is running. I just now need to deploy a second one, okay? So I just need to do count equals to 2. And also it's always good to format your code. So just do a Terraform main, format your file, just to make sure that it's okay. So it looks good. You know what? Let's go with 3. Yeah, that should be fine. Right? So let's do a Terraform apply. So I think while it's actually starting up, so right now what happens is that refreshing the state, it's getting the TF state file, it's getting the information, and I'll answer yes, I'm going to deploy 2 more resources. Cool. For example, this is what is happening in the back end. And while it's happening, right, let me bring you through how a TF state file looks like. Okay. Okay, so you can see, right, that actually Terraform has, like, for example, different values here. So it's actually really important, right, that when you're, and a caution note here is that your IP addresses, everything, right, maybe in this it's in this Terraform state file. Is there any way to block it? There's no way to block it, unfortunately. Okay, so you need to ensure that you secure your bucket by putting sufficient IAM securities on the bucket, right, so as to prevent random people from reading your TF state file. So here, right, it will tell us, like, for example, what provider I'm using, the instances that are being deployed, basically the CPU count, the type of VM that I want to run, T2 micro, what is my key name? Yeah, so this is the Terraform state file that you see. As mentioned, as you can see, right, there's a lot of private data that I can easily extract, which is why that you need to actually protect your Terraform state file properly. So next, right, I am actually going to, so you can see that actually 3 VMs have been deployed as a total. So let us go over to Amazon, right, and take a look. Okay, so yeah, you can see that actually it's initializing and it's already 3 VMs are already coming up. It has achieved my desired state of actually 3 VMs. It's done already. So right now, okay, I am actually going to show you how to do a remote executive, okay? And what it does, right, in remote exec is that it's basically going to actually install, like, for example, it's going to cat a simple file and install something. So let me just show you how it works, okay? So right now I am going to destroy my resources. So of course, the simple demo today is all EC2 as well as just pure EC2. But of course, you can Terraform more complex things like, for example, RDS, S3 onto it. Okay, so right now I'm just going to destroy my resources first. Okay, so I'll just say yes. Okay, so while it's destroying, we can start to work on our latest code. So our code here right now is that I'm going to, you know what, just now I created the security group, right? I'm using I'm using the default security group which is available in AWS. But now I want to create maybe a security group on my own and I attach it to this AWS instance. So let's code that out to see how it works. Okay, so right now I'm doing AWS security group and I'm actually doing sample security group, like for example this. So name, I'll just say like for example sample, and next is that I'll do egress. Egress, I think I need to do this. Okay, form underscore port equals to 0. Okay, so anyway, when you're doing security groups, as a good AWS practice, by the way, you shouldn't be exposing to anywhere. That is a good security practice. But for the sake of this demo, I'm just going to show you how it works. Okay, -1, and I'm going to declare my CIDR block. So this the CIDR block is basically where I am accessing it from, and 000 means just from anywhere. Of course, as mentioned again, you shouldn't be doing this, but for the sake of this demo, as it's a simple demo, that's what I'm doing. Okay, so right now I'm doing ingress as well, and I'm actually going to do a form port equals to so right now I'm actually doing a var.ssh where I can SSH in var.ssh underscore port and to underscore port equals to this as well. Okay, so then next I'm going to use protocol equals to TCP, and lastly I'm putting in the CIDR block again as well. Actually, I think it should be CIDR blocks if I'm not wrong. I think it should, yeah, it's CIDR blocks. Sorry, CIDR block. Okay, Terraform fmt main.ts file. Okay, all good. Everything looks fantastic. So right now I'm going to do a Terraform plan just to check if there's any issues. As mentioned again, when you do a Terraform plan, it is not going to. Okay, let's take a look what's wrong. So anyway, when something wrong like this comes up, right, it will tell you, like for example, what's the error, what's the issue, and from there, right, you can actually take a look at it and to see what is actually going wrong with this infrastructure. So I think here, right, on the other hand, I didn't put a -1 correctly. Okay, let me just try again. Appropriate value. Give me a minute. Okay. Resource AWS security group name sample egress from port. Yeah, this looks correct. Give me a second to figure out, but in any case, let me just get my code from here. So actually in Terraform as well, there's a lot of examples which you can actually use online, and you can actually use these resources in your code. So right now, let me just check again whether it's okay. Bear with me. Okay, yeah, looks good. All right. So right now, I'm going to attach this security group to this AWS instance. So I'll just do security groups equals to, I think, $. In the meantime, if you guys have any questions, feel free to speak out. I can still work while you guys are speaking. So feel free to ask me any questions when I'm typing this out. Okay. So right now I'm just checking if it's okay. Any questions so far? Okay. So right now I'm going to apply my infrastructure. Okay. 1 second. So right now I'm actually creating the infrastructure now, and it's actually going to be deployed into AWS. So while it's actually happening, let me see the chat group. Okay, how is the AWS key and SSH passed into the main.tf file? So the way it's being passed into the main.tf file, right, is actually basically here, this portion here. Sorry, give me a second. Okay, so what happens is that I already uploaded my public key into AWS actually. So in AWS, there's already aws.kp file over there. It's one of my PEMCAP keys there. And that's how it's actually being passed when I do a pub key name here. So if I go here, I just need to pass in the variable pub key name. Yeah, so that's what happens. Later on, I will show you the remote exec in which I am using AWS, right? Where I'm using my private key to do some special things into my environment. So just bear with me for a while, then you can see it. But basically now I have this already, it's up and I can SSH inside just to take a look. Let's SSH in. Sorry. Okay, yeah, looks good. So I can actually, I'm inside my AWS EC2 instance already. All good. So the last demo that I want to show is actually a remote exec, which I'll be doing this. Let me just do the remote exec, then I will answer the questions as well. So Terraform, let's destroy the state file first. Okay, so your questions like, for example, if let's say I want to install something, let's say in my AWS instance, if you have used Cloud Init before, it's very similar approach. So like, for example, what if I want to, let's say install, I don't know, like Apache, or I want to install curl or create a text message when it's being booted up. So is it possible to do it using Terraform specific, using Terraform only? The answer is yes. So we can do that using actually something called provisional remote exec. We can do that. Okay. So right now I'm doing remote, I think it's exec C. Okay. So this is where we declare the provisional remote exec. Then we do an inline equals to, let me get this. OF. Yeah. Okay, by the way. So right now I am doing an inline UF and I'm doing a sudo yum install wget. Then I'll just do echo hi into sample.txt. Okay, so just let me check why this is complaining. Okay, I think I know why. So EOF, that's strange. It should be that. Give me a second to just check this. Provisional remote exec. Sorry, yeah. Yeah, okay. Yeah, so just because I had this coded out just now. So let me just do a Terraform fmt main.tf. Okay, so what it's doing here is that it's just doing a remote exec. It's connecting via the EC2, my EC2 user IP name. It is passing in my private key, and basically I did a self.public IP, and yeah, I just put a timer of actually three seconds. So what happens is, let's say let's do a Terraform plan just to check. Okay, now I'm going to do a Terraform apply. Oops. Okay, So right now, while it's setting up, let me just see the chat channel if there are any for questions. All right. So yeah, so for to protect the state file, right? Usually in the S3 bucket, as mentioned, you will put in like, for example, IAM security rules, to say like only X amount. These people can only actually access the state file. It should be only, or you can set permissions on the S3 bucket to actually prevent people who are non-permission, right? To not access the bucket. Yeah. That is the way for like in AWS if you're storing into S3. Yeah, that's one example. Similarly, I think in like GCP or Azure, you can do similarly as well. Okay. Um, so if let's say the state file gets corrected or is inaccessible, how do you overcome such situations? How can I audit or know who made changes to the state file? Okay, so for auditing of the state files, I don't think you can audit the state file. I don't think you can do that, but you can audit the S3 bucket who has been accessing it via the API. I believe that's what I remember. I may not be totally correct here, but I can double check just to be very sure. Yeah. If the state file gets corrupted, right, what happens is that, or let's say is inaccessible, or actually usually if it gets corrupted, what happens is that you would do like, for example, I mean, I had one situation where my state file was like corrupted, and I think what happened was that it we had to actually remove all the infrastructure manually, which wasn't a very good thing. But I think in the latest versions of actually Terraform, there's a way to actually recover the state file. Again, this part I am not totally sure, but let me double check, Vinay, and I can get back to you. Yeah. What would you call? How does the development lifecycle look for infrastructure and code and Terraform specific? Do they follow typical SDLC? Okay, so in terms of the development lifecycle, right? For Terraform, and I think this question actually would be addressed when I show you the Jenkins combination with Terraform, to show you how I can actually deploy the infrastructure and use it in combination with a lifecycle tool, let's say using Jenkins to actually help automatically provision or destroy my infrastructure. Just give me a while, I can show you the example in a bit. Okay, so usually when multiple developers are working on the Terraform, right, what happens is that it's always a state lock issue. So if let's say I am working on it first, right? Okay, and if let's say I deploy my infrastructure, there is a state lock that's being applied to the Terraform file so much so that nobody else can actually access it. Yeah. So at that point of time, it's inaccessible for that point of time until my infrastructure is deployed. Then the state file is updated, and then the next developer can work on it. Yeah. So it is just like, for example, if you think about it in a database concept, or if let's say I have a file, I acquire the write lock on that file. I do whatever I need to do on it, and then I release it later. Then after someone else can come in and use it. Yeah. So as mentioned, the question which I'm not too sure about, which is the state file corruption. Let me get back to you, Vinay, on this one. Okay, so going back to my slides, is everyone okay so far? Hello? Okay, so I'll take it that everyone's okay. So right now what happens is that I am actually going to show you a CI/CD pipeline where I'm using Terraform and Kubernetes and Jenkins to actually deploy the infrastructure. I have Vault up there, okay, which actually does my secret management of my Mongo database. And the idea is that this is the overall architecture, what it's going to do. So Terraform creates the Kubernetes, deploys the apps, and creates Vault. In this part of the demo, however, Vault, I will not be redeploying again because I already have set it up, but I'll be doing from the for the Kubernetes and Mongo database, for example, to let you guys take a look how it's being done. Okay, so I can actually integrate Terraform very easily, right, with Jenkins. So let me just access my to those who are not sure about Jenkins, anyway, Jenkins is actually CI/CD tooling that you use to actually help to automate your build infrastructure or your applications. So what happens is that I already have created a Terraform file before this. And if we go and take a look at the repo, right, what happens is that basically it's reading from this Jenkins file. And like, for example, I can set the path. Now, I also do a Terraform delete to clean up any old states that are there before. I have my access key and my secret key. And basically, right, when I do my init, plan, and apply, my plan, right, I can actually just do, my apply, I can do an auto approve. So auto approve, what it means is that I do not need to, you saw me just now, I had to go in there and type yes, right, so that it can deploy. So for auto approve, it will actually automatically deploy it. Of course, you can use Jenkins to actually pipe this result to, let's say, a person who needs to approve it and approve it from there. You can always do that. Yeah. But for the sake of this demo, I'm just automating everything end to end. Okay. So right now, I'm just going to build my Kubernetes environment. Okay. So you can see that what happens is that there's a declarative checkout. It will set the Terraform path. It will delete any old states that I have there. And then it will do the init, plan, and apply. Yeah. So in the meantime, if there are any questions, is there any questions that anyone wants to ask? Okay. Is anyone using Terraform in their infrastructure today? Just a curious question. Hello? So I take it that everyone is using Terraform in some way or manner? Something, okay, all right, cool. Understood, okay. So anyway, for Terraform, right, what happens to get started on Terraform, right? You can always go to HashiCorp, Terraform, and you can actually see, like, for example, they have actually a very good, I would say, explanations and documents how you can actually use Terraform. And of course, you can actually sign up for the Terraform Cloud. So for Terraform Cloud, basically, as mentioned, you do not need to install Terraform itself. You can actually start using the cloud service as it goes. Yeah. So right now, there's actually, you can look at all the providers they have, and they have a lot of providers. Like they have GitLab, they have GitHub, they have public Oracle Cloud, they have Azure, they have a ton of things here actually in Terraform. In fact, you can actually, if you're doing software-defined wireless area networking, right, like SD-WAN, you can use Terraform to do that as well. So I also didn't know about it until I read about it a few days ago, and I was like, okay, that's really interesting. So there's actually a lot of other complex things that you can do with Terraform. Like for example, I want to Terraform, let's say a multi AZ infrastructure, right, in AWS. Can I do that? Yes, of course you can do that using Terraform, not an issue. So wait, okay, the CI/CD is still kicking off. Sorry, it's still happening. Okay, so right now I already have put it into my CI/CD. I was just setting it go ahead first. So from here, right, I can actually pipe out what is my application port number, my database port, my worker nodes, everything here. So for example, right, if I actually want to access my worker node IP, for example, it already has been Terraformed in AWS already. So let's take a look. I think it's called master. Yeah, AWS master. This is the one. Yeah, correct. So what happens is that it's initializing now the Kubernetes, and in fact, I already set up a very simple, right? I already, as using just that pipeline alone, I have set up a very simple one master and two worker node Kubernetes cluster with Mongo database installed on Kubernetes. So let's take a look. Okay. I think it's this 54. Is it this? Yeah, let me just check. Oh no, okay. I think this is Ubuntu. Okay, yeah, right. So if I do a kubectl, and those who do not know about or who are unfamiliar with Kubernetes, is basically a container orchestration platform. Okay, so it's not really it's not fully up yet. Yeah, it's still provisioning, I believe. Anyway, it's using kubeadm to actually install, and what happens is that basically it takes a bit of time to install. So just give it a bit of time, and it will be up. It should be fine. Maybe to let you guys see how it's actually being done behind the scenes, let me show you how it actually is happening in my master.terraform file. So okay, so I, as mentioned, I have actually a master and workers here. So what happens is that if you see, right, it's actually deploying the AWS instance as a worker, setting the instance group. And what happens is that I am putting a file called dataflow.worker user data.rendered. So what happens here is that it's actually reading from this script here. I can pass in a bash script, right? I can do that, and I'm actually installing Kubernetes from here straight into it into AWS EC2. And then after that, later, I'm just joining the cluster using a worker node. This is like for the worker node script. For the master node script, for example, is actually using this script to install using Kubernetes, right? So let's see if it's up ready. Okay. Okay, let me just try this guy on the other hand. Oh, I think I know why. I think I know why. Sorry. Okay, that's weird. That's interesting. Okay, I'm not sure why it went down today. Maybe something went wrong, but let me check it out why it's not working. And yeah, probably I can video record this portion again so that you guys have a better idea, but it was working a while ago. I'm not sure why it's not working now. But the idea is that basically with this, right, I can actually Terraform all my Kubernetes environment, and it'll all be up and running. So let me just do one more check just to make sure that it's okay. Just to double check. In the meantime, if you guys have any questions, feel free to ask me, and then update later I can answer your questions. Yeah, okay. I'm not sure why it's not working here. Sudo docker pl. Okay. I think because I'm pulling an old repo, that's why. Okay. Docker ps ctl. Okay. I think I know why. Yeah, but okay, this demo I can I can actually redo it and record it for you guys to let you guys take a look again. So I can definitely have a separate session on the CI/CD. I know that in this time I wasn't able to. There was something wrong, I think, with my script. But let me take a look at it. And of course, I can do a separate session to let you guys have a feel about how it works. Is there any other questions that you guys want to check? Or yeah, I haven't used Telegram. For me personally, I haven't used it. I haven't used it, but once I use it, it would be I mean I will usually put my feedback on like Medium or on GitHub. But I haven't used Telegram personally yet before. Yeah, no problem. Yeah, no problem. Uh, I think the video recording will be shared on YouTube, right? If I'm not wrong. Is that right?
Yeah, Adrian, you're right. So after this, SCS will share the video and post it on YouTube. I think it's also available on the SCS website.
Okay, understood. Yeah, understood where you guys are coming from. Yeah. So is it okay to share some of your hobby projects that you're using Terraform? Yep, sure, can. It's actually is in my GitHub, so you can go ahead and download it and try it out. In fact, it has the Terraform for the Kubernetes there. I'm just not sure why it did not work this time. I'm trying to figure out why. But yes, you can definitely download it and you can definitely do a Git clone. And I'm going to just put my GitHub link here so that you guys, like for example, that this is the Terraform K8, for example, on AWS. You can definitely use that. It's so to know, this is not to be used in production environment. This is like, for example, you want a test cluster be up, test it, then bring it down. Is that sort of concept? It's not meant for a full production because there's a lot of like security concerns when you're actually deploying Kubernetes, which you need to build it more into the script. Yeah. Just let me see if I am missing any questions here. Okay. Okay, let me just go from the top. Sorry, I think there were a few questions that were missed. Okay, can we get the slides? Yes, yes. You can get the slide. Not a problem. You can do that. Okay, let me see any more questions. Okay, so there's a question about configuration drift. So there is a way to detect and manage drift with Terraform. And if I am not wrong, what happens is that we will use something called Terraform. Okay, so the command to actually reconcile the real world drift, all right, is actually using something called Terraform refresh, if I'm not wrong, and it's basically used to actually drift. For those who are not sure about what it is, right? It's basically a term for where the real world state of your infrastructure actually differs from the state that you have actually defined in your configuration. Okay, so that is the concept of what drift to those people who aren't really sure what drift is, what drift means. So external to your configuration, drift occurs when, like for example, I add in a resource randomly into AWS, or I terminate a resource purposely. I go into the console and I terminate it, or I use maybe a separate automation tool by accident, I say using Ansible, I do something to that infrastructure which I have provisioned using Terraform. So what happens is that we can use Terraform refresh to actually reconcile the command is to reconcile the real world drift. The plan command also is used to actually, after you have done the refresh, you will do a Terraform plan. And actually to manage your options for the drift, right, you use something called Terraform config. Yeah, but for me, most of the time to actually track the Terraform states, right, for it being, to reconcile the drift, right, I will usually use Terraform refresh to check the state between what has been deployed and what is actually in my Terraform state file. Yeah. I hope that answers your question. And in fact, there's this really good blog, if I'm not wrong. Let me just search on it. Give me a second just to find it. Yeah, this is the one. Yeah, can. So I think there's like 8 minutes left. Does anyone have any questions? Okay, I realized that sometimes when I am refactoring Terraform configuration variable, plan decides to destroy and recreate. Okay, so yeah, okay, so it does. So what happens is that it does okay, for this actually there's no really way to overcome it. Okay, so I have encountered this before as well. As the best of my experience, right? Okay, so the question is that basically Terraform, when I think Ifan was asking, right, that sometimes when he's refactoring Terraform configurations like variable names or whichever, right, the plan actually destroys and recreate the resources instead. So in fact, in my demo just now, right, in fact, if I actually had deployed a counter of 2, let's say I deployed 2 resources, right, and let's say I embed my remote exec file script inside immediately, right, it would have actually destroyed my current resources and actually redeployed new ones and installed it there. So is there a way to overcome it? For me so far, as to the best of my knowledge, there's no really way to overcome it, because Terraform actually just states like what is the end state and it goes towards achieving it. But I may be wrong. I can do a double check and let me try out to see if there's any other way to actually deal with this. But at least for this question so far, I don't have an answer yet as to how I can overcome this, because I also have hit into a few issues like this before. Yeah. But good question. That I'll check on it as well. Can I push the main.tf in a code repo like GitHub a bit? Yes. Of course you can. Can you push a code to manage the versioning? No. So what is in S3, right, is in the state file. So the main.tf file, right, is in GitHub. Yeah. So if you see here, right, so the main.tf file, right, is actually here. Here's my main.tf file. It's in GitHub where I can do versioning control. The tf state file is the one that is in the S3 bucket. Yeah. So to clear up the confusion, I mean, you can of course push your tf state file into GitHub. I don't see why you can't do it, but the question is why? Because then you will be exposed, and if it's you'll be actually exposing the tf state file to the rest of the world, which kind of doesn't make sense. You might as well save the tf state file into an S3 bucket. Yeah. Yeah, no problem. Yeah, so Ifan's a good question, man. I also am not sure about that, so I need to check. Yeah, let me write that down. Or if I can get the questions later, would be great. Then I can help to look into it. Any other questions? No? Okay, I think I'm done then. Yeah.
That's it, Adrian?
Yeah, that's it.
Right. Adrian, thanks for taking time out and sharing what you know about Terraform. I think it is a great sharing session. Automation is definitely key to a lot of our conversation in today's world, right? Especially when you need to manage a vast estate of clouds deployments, and also double quick time. Yeah, so it's definitely an interesting tool to take us into a more agile, right, and fast-paced world, right? So thanks, Adrian. And I think that concludes the session. I would like to thank everyone for joining us today, right? As a follow-up, we will actually archive the questions so that Adrian can follow up on some of the outstanding questions or some of the things that he will clarify. And also updates everyone via SCS. Okay, so there will be a follow-up email from this session, right, where Catherine will share with you the slides and also an survey, right, on this session today. So please help to provide your feedback so that we can actually continue to arrange and organize more meaningful sessions. In addition to that, there was also a question on the video recording. Yeah, so once it's ready, it'll be posted on SCS, and again, you'll be informed via email on the link for you to access and download. Okay.
Yeah. No problem.
All right. We also like to keep our time to, the hour is getting late on a Friday evening. Thank you for joining us again. And I hope to see you in future events and webinars. Right. So I wish everybody a very good weekend ahead.
Yep. Thank you.
Right. Thanks everyone.
Richard. Thanks, Richard. Thanks, Wai Xiang. Thanks. Bye-bye.